Electrocution on construction sites, particularly during tasks like siding installation, underscores the critical importance of adhering to electrical safety protocols. Temporary electrical wiring is frequently used to supply power to construction sites, and while it provides necessary electricity for tools and equipment, it also presents significant hazards if not properly installed, maintained, and respected. One of the primary dangers associated with temporary wiring is the potential for direct contact with live electrical conductors. This can occur if wiring is exposed, insulation is damaged, or workers inadvertently come into contact with energized parts. Scaffolding, often used during siding installation and other exterior work, introduces an additional risk factor. Elevated work platforms can bring workers closer to overhead power lines or other electrical hazards, increasing the likelihood of accidental contact. To mitigate these risks, a comprehensive approach to electrical safety is essential. This includes thorough planning, proper installation practices, regular inspections, and comprehensive training for all personnel on site. Firstly, a qualified electrician should be responsible for designing and installing the temporary electrical system. This ensures that the wiring meets all applicable codes and standards, including the National Electrical Code, or NEC. The NEC provides specific guidelines for temporary wiring, covering aspects such as conductor size, overcurrent protection, grounding, and wiring methods. Secondly, all temporary wiring must be properly grounded to minimize the risk of electric shock. Grounding provides a low impedance path for fault current to return to the source, allowing overcurrent protective devices like circuit breakers or fuses to trip and to energize the circuit. Ground fault circuit interrupters, or GFCIs, are also crucial for protecting workers from electrical shock. GFCIs monitor the current balance between the hot and neutral conductors in a circuit. If a ground fault occurs, indicating that current is leaking to ground, the GFCI will quickly trip the circuit, interrupting the flow of electricity and preventing a potentially fatal shock. Thirdly, wiring must be protected from physical damage. This includes using appropriate wiring methods such as cable trays or conduit to shield conductors from abrasion, impact, and other hazards. Where wiring is exposed, it should be elevated or otherwise protected to prevent accidental contact. Fourthly, regular inspections of the temporary electrical system should be conducted to identify any potential hazards, such as damaged insulation, loose connections, or exposed wiring. These inspections should be performed by a qualified person and any defects should be promptly corrected. Fifthly, all workers on site must receive comprehensive training on electrical safety. This training should cover topics such as the hazards of electricity, safe work practices, the proper use of personal protective equipment, and emergency procedures. Workers should be taught to recognize and avoid electrical hazards, and they should be empowered to report any unsafe conditions. Personal protective equipment, or PPE, plays a vital role in protecting workers from electrical hazards. This includes items such as insulated gloves, safety glasses, and hard hats. Insulated gloves are designed to provide protection against electric shock, and they should be used whenever working with or near energized electrical equipment. Safety glasses protect the eyes from arc flash, which is a dangerous electrical explosion that can cause serious burns and blindness. Hard hats protect the head from impact and electrical shock. In addition to PPE, other safety measures can be implemented to further reduce the risk of electrocution. These include maintaining safe distances from overhead power lines, using insulated tools, and de-energizing equipment before performing any maintenance or repairs. Before commencing any work near overhead power lines, workers should contact the utility company to request that the power lines be de-energized or insulated. If de-energizing or insulation is not possible, workers should maintain a safe distance from the power lines, as specified by OSHA regulations. For example, for power lines operating at 50 kV or kilovolts or less, the minimum safe distance is 10 feet. Insulated tools are designed to protect workers from electric shock when working on or near energized electrical equipment. These tools have a non-conductive coating that prevents electricity from flowing through the tool and into the worker's body. Energizing equipment before performing any maintenance or repairs is one of the most effective ways to prevent electrocution. Before starting work, workers should verify that the equipment is de-energized by using a voltage tester. Lockout/tagout procedures should be followed to ensure that the equipment remains de-energized while work is being performed. Lockout/tagout involves disconnecting the equipment from its power source and attaching a lock and tag to the disconnect switch to prevent it from being accidentally re-energized. Furthermore, site-specific safety plans are indispensable. These plans should be tailored to the unique hazards present at each construction site and should outline the specific safety procedures and precautions that must be followed. The plan should address potential electrical hazards, including temporary wiring, overhead power lines, and underground utilities. It should also include procedures for identifying and controlling these hazards. Emergency preparedness is another critical aspect of electrical safety on construction sites. Workers should be trained on what to do in the event of an electrical accident, including how to safely rescue a victim of electrocution and how to administer first aid. Emergency contact information should be readily available, and there should be a designated person responsible for coordinating emergency response efforts. In the specific scenario of installing siding, particular attention must be paid to the location of electrical wiring, both permanent and temporary. Siding installers should carefully inspect the area before starting work to identify any potential electrical hazards. They should also be aware of the location of overhead power lines and maintain a safe distance from them. When working near electrical wiring, installers should use non-conductive tools and equipment to minimize the risk of electric shock. They should also avoid using metal ladders or scaffolding near electrical wiring. Instead, they should use fiberglass or wooden ladders and scaffolding. Regular safety meetings and toolbox talks can help to reinforce electrical safety principles and keep workers informed of potential hazards. These meetings should cover topics such as the hazards of electricity, safe work practices, and the proper use of PPE. They should also provide an opportunity for workers to ask questions and raise concerns about electrical safety. Continuous improvement is essential for maintaining a safe work environment. Construction companies should regularly review their electrical safety programs and procedures to identify areas for improvement. They should also stay up to date on the latest safety standards and regulations. By implementing these comprehensive electrical safety measures, construction companies can significantly reduce the risk of electrocution and create a safer work environment for their employees. Specific examples of NEC requirements for temporary wiring that are particularly relevant to construction sites. Firstly, Section 590.4 addresses general requirements for temporary wiring, including the need for it to be mechanically protected. Secondly, Section 590.4 B covers branch circuits and requires that all receptacles be of the grounding type and be protected by GFCIs. Thirdly, Section 590.4 D addresses disconnecting means and requires that each branch circuit have a readily accessible disconnecting means. Fourthly, Section 590.6 covers grounding and requires that all temporary wiring systems be properly grounded. Looking at overcurrent protection, the NEC mandates that temporary wiring circuits must have appropriate overcurrent protection, such as circuit breakers or fuses, to prevent overloads and short circuits. These devices must be properly sized to protect the conductors they serve and must be readily accessible in case of a fault. Grounding and bonding are fundamental to electrical safety. Temporary wiring systems must be properly grounded and bonded to minimize the risk of electric shock. Grounding provides a low impedance path for fault current to return to the source, allowing overcurrent protective devices to trip and to energize the circuit. Bonding ensures that all metal parts of the electrical system are electrically connected, preventing voltage differences that could create a shock hazard. Ground fault circuit interrupters, or GFCIs, are life-saving devices that protect workers from electrical shock. GFCIs monitor the current balance between the hot and neutral conductors in a circuit. If a ground fault occurs, indicating that current is leaking to ground, The GFCI will quickly trip the circuit, interrupting the flow of electricity and preventing a potentially fatal shock. The NEC requires the use of GFCIs in many temporary wiring applications, particularly in wet or damp locations and where workers are likely to be in contact with grounded surfaces. Safe work practices are essential for preventing electrical accidents on construction sites. These practices include always energizing equipment before performing any maintenance or repairs, using insulated tools, maintaining safe distances from overhead power lines, and wearing appropriate personal protective equipment. Workers should also be trained to recognize and avoid electrical hazards and to report any unsafe conditions to their supervisor. Emergency procedures should be in place to address electrical accidents. These procedures should include instructions on how to safely rescue a victim of electrocution, how to administer first aid, and how to contact emergency services. Workers should be familiar with these procedures and should know how to respond in the event of an electrical emergency. The Occupational Safety and Health Administration, or OSHA, has specific regulations regarding electrical safety on construction sites. These regulations cover a wide range of topics, including temporary wiring, grounding, GFCIs, and safe work practices. Construction companies must comply with these regulations to ensure the safety of their employees. OSHA also conducts inspections of construction sites to ensure compliance with its regulations. If OSHA finds violations of its regulations, it can issue citations and fines. Construction companies should conduct regular self-inspections to identify and correct any potential hazards before OSHA arrives. The design of temporary electrical systems requires careful consideration of several factors. These include the load requirements of the equipment being powered, the voltage and current ratings of the wiring and components, and the environmental conditions at the construction site. A qualified electrician should be responsible for designing the temporary electrical system to ensure that it meets all applicable codes and standards and that it is safe for workers to use. Installation of temporary wiring must be performed by qualified personnel in accordance with the NEC and other applicable standards. This includes ensuring that the wiring is properly supported, protected from physical damage, and grounded. All connections must be tight and secure to prevent overheating and electrical faults. Regular inspections and maintenance are essential for ensuring the continued safety of temporary electrical systems. Inspections should be conducted regularly to identify any potential hazards, such as damaged insulation, loose connections, or exposed wiring. Maintenance should be performed as needed to correct any defects and to prevent future problems. Training and education are critical for ensuring that workers understand the hazards of electricity and how to work safely around it. Training should cover topics such as the basics of electricity, the hazards of electrical shock, safe work practices, and the proper use of personal protective equipment. Workers should also be trained on emergency procedures and how to respond in the event of an electrical accident. In conclusion, electrical safety is paramount on construction sites, and particularly during siding installation where workers may be exposed to temporary wiring and other electrical hazards. A combination of careful planning, proper installation practices, regular inspections, comprehensive training, and adherence to OSHA regulations is essential for preventing electrocution and creating a safe work environment. By prioritizing electrical safety, construction companies can protect their employees from harm and ensure that projects are completed safely and efficiently.